All right, Ben. What are we doing today? You got a haircut, by the way. You look
did,
good.
and I put gel in it.
Look at that. Different man.
Don't expect that will continue very much, because I just as soon not deal with my hair at all. It's such a distraction and a waste of time in the morning.
You'd rather just get out of the shower and go right to work, right?
Well, I would. I mean, I do like to get dressed between there. But yeah, the hair, I don't know. I guess I should be grateful. A lot of people don't have any and wish they did. I wouldn't be too sad if I didn't. Anyway, we're here to actually talk about programming. And this week we're going to continue our discussions of good programming patterns and practices and things like that. We seem to have gotten a good response from our video about what and how. So we find that encouraging that you think that's interesting, and we're going to keep talking about stuff like that. So today we're going over async, callbacks, and side effects, particularly focused on JavaScript. So we'll start, I guess, talking about async, right?
Yeah.
All right, so...
Why do we have async?
Because we have to. Because we live in the real world. Back in the old days, when the computer system was pretty much self-contained, everything lived inside the computer, it wasn't a big deal for your program to say, do this, and then access this resource, and then do this, and access this resource, and do something with those things. Because everything was right there, and I guess a lot of the time, you just load the whole program in for the disk, so you didn't even have to wait for that. Everything you wanted was there, and you could run your program top to bottom without having to wait for much, really. But these days, if you consider what a web application is, so we have our interface in the front end. You probably can't even read this. It says front end. So that's part of the application that runs on the browser on your computer, and then there's data that lives out here in a database. And then we have a network connection in between.
The cloud, right?
Yeah, and then in the cloud.
There you go.
And then we've got other resources over here. Maybe we've got an image that loads from some image
That's a nice
site.
tree. Yeah.
Hey, it's a tree. You recognize it. Thanks.
Broccoli.
And all this goes through the cloud. And what happens if the cloud's having a bad day? Or this breaks or something, or it's just slow. It takes a lot of time to gather in all of these resources and deal with this stuff over the network, and we really can't load everything in beforehand, because that would take a long time, and we don't even know necessarily what we're going to need. So we have to deal with things asynchronously. I guess to explain it this way, the alternative to asynchronous is synchronously, and it is possible. You can, in your JavaScript, say, go get this resource synchronously. And what that means is JavaScript is going to go say, hey, I need this thing.
And your screen looks just like that.
And then the thing comes back, and then your program can go on. And the user wants to scroll up and down, and the browser's frozen, and they're frustrated because everything's stopped. So we invented asynchronicity.
Oh,
Is that a word?
You just invented it.
We invented async, where you can tell your program to go get something, and then the thread keeps going. You can scroll up and down, click on links and whatever, and when it comes back, you're notified. So I guess in a nutshell, asynchrony allows you to do things, let them cook for a minute, and then be notified when they're done, so that you can go on with your life.
So that brings us back. Now that is async, and it describes that you described perfectly. Now we need to talk about what do we do? How do we do async? That's where callbacks come in, right?
Well, the gist of it is, like I want a lasagna. I say, hey Jared, make me a lasagna. I don't want to stand around here waiting. I don't even know if you can make lasagna, but I don't want to stand here
waiting.
It
wouldn't taste very good.
For you to come back with the lasagna. So I'll say, make me lasagna, and when you're done with that, this is where I'll be. And then I can leave.
So these are directions to you, so I'm done cooking, and I can come to you and say, oh, well, I got to you, thanks.
Oh,
It's ready.
great, thanks. Now I got my lasagna. Now I can go on with what I was doing.
So you basically can stick or it's like sticking the casserole in the oven and doing the dishes. Same type of thing, right?
Yeah, and then you set a timer on the oven, and the timer goes ding. You know your casserole's done. That timer, that ding,
Is our callback.
is what notifies you, the program, that it's done. That's the callback.
So let's give an example in JavaScript real quick of a callback. So we'll do a simple example exactly from what Ben just said. Let's do a, usually you'll see something like this. We'll just create a fake function that it's already been made for us. And it's get JSON file. How's that sound? And what we do is we just pass it the URL. So we could say HTTP something, somewhere out in the web. And then this is how, a lot of times they do things in JavaScript land, they just give it a callback, right? This is a function. We talked a lot about functions, how you can pass them as variables. And you're like, hey, when you get that file, give me the data. I want that data, and I'm going to do something with that data. So in most cases, you'll probably say, hey, well, this is a config file, so I'll say var config equals json.parse. And now, I have my config file, right?
Yeah, and this is, by the way, one of the beautiful things about a functional programming language is that this function is a thing that we handed off and says, there's some instructions to do, I told you what to do, and you're gonna do it when you're done. That's really cool.
So basically, this is a lot like how you described to me. This function is kind of like the paper that said where you'll be.
Right.
Because you're saying, hey, this is where I'll be, and you can do it.
It's like, go get me a lasagna, and then when you have the lasagna, I want you to bring it to me, and this is where I'll be.
Exactly. And what's great is it remembers your context too. So this function that you had, if you had data out here, some var name, right? This is what's so wonderful about scope, functional scope, is this function has access to that. It can do some other things with variables outside of that function.
Right.
So that's the beauty of callbacks, asynchrony and callbacks. This is what allows the web also to respond to your clicks. You know how we do our click, the observing system, they use a callback system, so that you want to listen to a click, you give it a function, and it gives you the event back and where it's been clicked and so forth. So we not only use it to go over the wire, but we also use it for the UI. Because we don't know when it's going to get called, we just know sometime in the future it's going to get called.
Yeah, this is pretty much the essence of reactive programming. And when you're dealing with user interfaces and networks and things, there's really no other option.
So that segues us good. Callbacks are wonderful. Like Ben said, this is part of the beauty of JavaScript. How we can pass a function as a parameter, and then it gets run sometime in the future by somebody else. Somebody else invokes that, not us.
Mm-hmm.
Somebody else. So, but there is a problem with that. Especially with this one. When you go over the wire, you described sometimes the internet has a bad day. Cloud with the frowny face. So you have to plan for errors.
Right.
Now this is where it gets a little hairy, and we're going to probably strike some chords with some people. There's this fight going on in the Node.js community on whether callbacks are sufficient or we should use promises and futures of sort. And I'll tell you what I personally believe, and you can take it for what it's worth. I think that if there's no side effects, hence our next topic, if there's no side effects, use a function callback.
And if nothing can go wrong?
If nothing can go wrong, use a function callback.
You're pretty much guaranteed, because what this says is do this thing, and when you're successful, do this thing.
Right.
The problem is if there's a possibility of failure. Now,
that gets hairy, right? So let's write that out, because now it becomes, instead of this, it becomes, you'll see this in Node.js if you guys are Node fans. We have to check for an error before we even get to the data. So now we're sitting here, and the first thing, you said this best, I'd like you to explain it again.
So, when I'm looking at a program, think about the readability impact of this. I want to know what this function does, So, okay, get JSON file, that makes sense. I handed a URL and here's a callback, and then I handle an error. Is that really the most important thing that this function does? Is that what I wrote this function to do? No! But yet, I have to get through this error handling nonsense before I can get onto the meat. And more frustratingly is, the meat of the function is hidden inside this silly else statement. Like, it doesn't matter. Like, I don't care about it. The most important thing here is here. Why?
And yet you have to go through all this and then jump in another level to see what you meant to do with this.
And in Node, even if you know you're really darn sure that there isn't going to be a problem, you gotta check for the error anyway. I'm sorry.
Yeah.
You just gotta do it.
And so, in my opinion, this is where it starts. When you can have errors, which are side effects, you need something better and bigger to handle the problem. Now this, I want to accentuate this a little bit, because at our work we created a promise of sorts. We call it future. So we're going to reference, if we ever say future, we really mean a promise. And I know that some people call them either or. I don't know what the deal is.
I think ECMA is calling them promises in the new version of JavaScript.
So that's what they are. They're the same thing, but this is where our built-in, our company had us build our function, our futures, and there's things that it can handle. For example, it can handle errors, it can handle successes, it can handle canceled, it can handle timed out. So can you imagine this now? Okay, let's just throw this out. We thought it got ugly in Node with just 2 options. Well, can you imagine the ugliness that this would incur if we did this? If we said, well, there might be an error. Well, it is timed out, right? Because we cared it might have timed out. What else is there? There's
it was canceled.
Is canceled. What else? That was is time. I think error. Then I think that's it. And then data, right? There might be something else. I think that's it. But now,
so look at the
I think we even got off the page, off the camera here.
Can we see this?
No, we can't even see all that, but that's...
Oh. Well, yeah.
You get the point.
So look at the function signature here. What does this function actually care about? Yeah, we can't see it anymore. It fell off the edge of the world.
Do you know what's interesting is they say a lot, when your function has so many parameters, it's time to build an object.
Yeah.
And this is what we're going to discuss today, is futures. So let's change this a little bit. Let's maybe write an example. If you guys can keep this in mind, this is the what I would say the nasty way. And because there's side effects, and now you're having to if check everything, and I'm a big guy that says if you have ifs, you better have a good reason. This is not a good reason to me.
So before we get to the pure solution of the future,
okay, yeah. Like search.
I just thought of this, but there is a way that we could refactor this instead of passing in all of these arguments.
Okay.
To that one callback, something we could do is say,
oh yeah, you pass in the functions.
Food. Then we can have a location or whatever. Then we can have a success.
Oh, success function, right?
A success callback, an error callback, a timed out callback. So we could maybe do it this way, and I like this even better. But if you wanted to do these in line with function literals, as you would most of the time want to do, even this is going to get out of hand, even though it's a little better.
Yeah.
But the future that we're talking about essentially does this, but it's packaged up in a format that I think is a lot more useful.
So we before we started this video, we talked about how can we describe a callback, and I actually think this is brilliant because it took us a while to think of it. But let's draw it out. So this is how you can understand what a callback is. A callback is essentially your function scope is like a lamp. So we have this lamp here. It needs to be turned on, so it has this little cord, right? What do we need?
Well, we need power. We got to plug it into something, right?
So there, we need an outlet, right? There's the outlet. Let's plug it in. And what happens?
Well, the lamp comes
The
on.
lamp comes on. Well, that's great, isn't it? That's
But you know, that lamp really isn't big enough to light my whole living room.
oh. So what else would you like to have?
I need another lamp.
Oh, you need another lamp. Okay, so we need another lamp.
I want a TV.
We've got a lot of dangling cords so far, so we need a TV.
And somewhere to plug in my computer.
Oh, okay, and a computer. We have a problem here.
Wait, my lamp and my TV don't work.
Yeah, just this one. It's not that you don't have the callbacks written, right? The callback represents the handler, right? Is the cord.
The lamp and the TV have everything they need to work, except for the power.
So they need data, right?
So there's only one. I suppose we could run extension cords to other plugs around the house.
But we might run out. Let's say we had 2 more. We were lucky. But I've been in a house where you couldn't find a plug to save your life. So what did I do? I ran to the store and I grabbed something really cool.
Yeah. Before you say what that was, I just want to point out that as programmers, we're always looking for patterns and looking for ways to optimize and simplify.
Okay.
All of these need the same thing. They just need power. We have a plug here that gives them power. Why don't we can't we just use this plug to power everything?
Well, sure.
So what did you find at the hardware store that you were going to say?
Oh, I just needed a power strip, didn't I? So let's draw a power strip here. Oh, this is a fancy power strip. So now we have these power strips. And now we can plug that into there, and voila.
Let's plug it into that one.
Okay, let's keep it consistent.
Unplug the lamp.
Oh yeah, that's a good idea. So we unplug the lamp, and now we have it plugged into there. So now all of these just go chunk, and that one gets going down. So let's get rid of that, and then that one gets to here. So now go ahead.
What's more is this power strip has a switch on it.
Yeah, it does, doesn't it?
So by flipping on this one switch,
I just realized something too. Right? Go on.
I can turn on all of this stuff at the same time. In essence, all 3 of these objects are responding to the same event. The same thing happens, and they all care about it.
Then I went to the store and I went and got a surge protector. It's kind of like the
air handling.
Yeah, the air handling, right? So this, in essence, the surge protector, well, the power strip is the first way to resolve it, but we need a little more, so we packed in a surge protector, which is the air handler, and then we could find something for cancellables and timed out and so forth. But
right, yeah, we could have a battery backup in case something times out.
Yeah,
or the power goes out. And then
exactly. So we could engineer something, right? But this is essentially, this right here is what the future is. It's funny, the future. It's what the promises are. Now,
the promise of the future.
Promise of the future. So when people get all up in arms about this pattern, I think to myself, they must not like power strips. They must like to have to go find the...
They must not like reuse and common patterns.
Or maybe they have one lamp in their house.
And I don't know. To me, this just makes sense. Because all of these things want the same thing. With a regular callback, you're going to have 3 of these. You're going to have to cut holes in your walls and put in more plugs to do this job. With futures, though, and methods that Jared's going to show you soon, all of these things can respond to the same event with good air handling and fault protection and all kinds of
The other thing I like about this is you can't move this out of your wall. Okay, this source of data is there, but this little future mechanism, I can unplug it from there and stick it in some other plug, and then get that functionality somewhere else. That's the other thing about callbacks is you can't get out of from here to here. That's where you live. The cord itself represents the callback. This is your function that represents what it can do. It should work. If it got its data, it would all work. We're waiting on the data. So let's talk about why futures are so cool. This becomes an object, which then means you can pass it around. The callback is beautiful because you can pass a callback around, but that callback can't then tell everybody else what to do.
That callback is pretty specifically bound to the object that created it and the event that it's reacting to. And as programmers, we're always really nervous of anything that's tightly bound. If you see anything tightly bound that might be reusable, you got to get it out of there. And the future, being the intermediary object here, allows us to free these objects and these callbacks.
So let's see how it looks. So we'll do the same example that we did before, and but we'll do it with a future instead. So you talked about lots of problems. The network could go down.
Mm-hmm.
You may care that it may take too long. Let's say the network was slow that day,
Or that I wasn't authenticated.
or that you weren't authenticated. So there's lots of things that error handling that you need to do.
That's a good one too.
Please expand.
Well, with the callback, if you're unauthenticated, that's something that you're going to try and do again. Well, maybe not. I'm going to hold on to that. Never mind. Carry on.
Complete that thought. So what we need to do is we need to create a function. Remember how we had a function that said the interface was get JSON file.
Mm-hmm.
So instead of passing in a callback, because remember that's our chord, what we need to do is we need to say, hey, we want to get a future from you. So we're really interested in this file. So this is our future. So our future equals get. Look how simple this signature gets too. So now we just pass in the URL, right?
Speaking of what and how, this is pretty descriptive what. There isn't any other stuff over here confusing the reader what's going on here.
And this is actually really descriptive too, because you're like saying, hey, this is a promise to get a file. This isn't the file itself. This is where side effects come in. This is, if you guys aren't familiar with Eric Myers, he used to work for Microsoft. I think he's now working a lot with Netflix. But he came from the world of Haskell, and he's also the person who made Link inside of C#. Brilliant man. I suggest to go to Channel 9 and watch every video you can of him. I spend hours watching him, and he's brilliant. But he talked about this in Haskell. You can't even deal with the I/O, so the data on your hard drive, without side effects. Because
when we talk about side effects, one of the things we mean is in Haskell, because it's purely functional, what happens inside of a function stays. It's like Las Vegas. What happens in there stays in there. Nothing inside your function can reach out of the function, and nothing outside can get in, except as is passed through the parameters and returned at the end of the function.
correct.
So if you think about I/O, we want to do stuff on a disk. Well, the disk is outside of the function. So in Haskell, I'm stealing your thunder.
No, I love this. This is great.
But in Haskell, they had to make some special allowances for special operations that had side effects that could reach outside of the function. But there's side effects.
But yeah, so that's why it's so important to understand what side effects mean. So we're saying this is a future file, we hope, right?
Mm-hmm.
We don't have the value yet. So how do we get the value? We've got this promise that we're going to get one. So if we really care about it successful and we want to get the contents of that file, we say futurefile.then. And that's where we pass in our callback, or our plug, remember?
Ah,
So now this is our plug that's going into, see, remember this here is our power strip, this here is our plug. So now we're like, hey, I've got some cool functionality, I want to get the file data. Now look at that, how big did our parameters get on that one? This represents our data getting back. Let's write that out, let's make that clear. So now we've got our data back, right? And we could do that whole JSON thing and get it out. Well, what we could also do is we could say, you may just care if it's successful, right? You're like, hey, just do this if it's successful. I don't care if the network goes down.
so what if you don't get the data? What if it's not successful? Won't this part of the program crash?
Nope, it will never run.
So I don't have to check for the validity of the data or make sure that it came back all right or that I was authorized.
Nope.
This never even gets touched if this future isn't successful.
Correct, isn't that beautiful? All you can read your file now, your JavaScript file, and understand exactly how the program should function. Like, oh, this is what it does when it's successful. But this is really cool. But what's even cooler about this is that you can pass this file around, pass this future around. So I could take this as a variable now, right? Pass it to somebody else in some other scope. And then they can do a then on it. Because they want to know when it's done. So here we go. Now that's the TV and the other lamp, right?
Mhm.
They came and pulled themselves and put themselves. This guy doesn't get interfere with whether they get the knowledge or not. What's going to happen is the future is going to say, oh, who's interested? Okay, you were interested, you were interested, you were interested. There you go. And it runs it. It's a beautiful concept. But let's look at the interface now with, you can chain them with our futures. This is a little different. I have a huge opinion on futures and continuations and how they should be separated and not in the same package.
Yeah,
That's
if
another.
anybody on the ECMA committee is listening, we have some advice for you.
I just believe that you should keep the responsibilities separate because to me, the chaining, returning the same future over and over is far more powerful and far more beneficial because a lot of times you'll want to return then, so you'll return this future to somebody else, but do something that you want to do, and it doesn't work when you do continuations because what it means is this guy will get it and then you'll get it.
Yeah, this will be different between our futures in the base library and which we're going to have on our website when we have our website, which is coming along very soon. Our futures return themselves on then. So you could say then, dot then, dot then, dot then.
And it's actually the same.
It's the same future. The ECMA promises are different. They're actually continuations, which are a little different. We have one of those too.
Yes.
But just know that you'll see us chaining these, and not everybody does it that way.
So we want to see if there's an error. So we have this another function on a future. So we're chaining it here and saying, hey, if error, now we care about the error. Look at how beautiful this is too. Wow. I don't even have to check to see if there's an error. If I get here, there's an error.
This is like a cooking show. Look how golden brown it is. Isn't that fantastic?
I mean,
I want to eat it.
It gets so cool. Now let's do something even cooler, right? Let's say we want to set a timeout. We really don't want this to take more than 2 seconds. So we have a function. We have a function on our future, and you say, hey, I want to set the timeout to 2 seconds, and it's in milliseconds. And then, right? So now we're down here again. So set timeout to. Now we do if timed out. If timed. Oh, that was a D. I forgot the D in there. Timed out. Do this. Now this is really ugly because we're kind of chaining along, but this is beautiful. This says, hey, if this doesn't come back in 2 seconds, guess what gets called?
If timed out.
If timed out.
Does this get called?
Nope.
Oh, good.
Error doesn't get called because it wasn't an error. It got timed out. Well, the beautiful thing is there's another thing called cancel. Cancel does get called when it times out because what happens is this set timeout, it calls a cancel on the future. The future has a, I'm going to erase this, I hope nobody minds. We're going to go back up here. Future has another property on it that says there's times in your programming, let's say somebody clicks on a button, you need to go get a file, and they're like, oh, never mind, I don't want to do that anymore, right? Well, too late. Your callback's in, you're stuck. Well, in futures, that's not the way it is, because you don't want that future then, right? So let's say we had the future file then here still. We'll just do a, right? We don't want this called because the user went on, and what if it comes back, it's going to change the UI and it's going to drive them crazy.
Yeah.
So what we can do then is when they click somewhere else, we can say pass the future to somebody that doesn't know what it's doing, but they can simply say cancel. Now, this future will never be called.
And everything that's plugged into it
Also gets canceled.
Because all that stuff's routing through the one future, all of that stuff reaps the benefit of that future being canceled.
So this is where when you start dealing with futures, there is some complexity. Your brain kind of gets in a knot. I'm going to write right now how we write our future interface, which if ECMAScript committee is looking to, this I think is a good way to write it. But this is why the futures and promises are promising. is that you have all this ability. I mean, one of the things that we did with the cancel is we had this infinite scrolling of items, and well, sometimes they'd be scrolling so fast that before they even got the data from the database, right, it'd be out of the screen.
So we didn't have to draw that DOM node anymore. We could just cancel the drawing of that thing.
We just said cancel.
And we didn't have to waste the CPU cycles of putting that thing on there.
That is the beauty of it all. So now let's talk about how we can make one. I'm going to make a short one.
Okay. You may want to scoot over that way a little because we keep running off the side.
Okay, so I don't know where we're centered at. Okay, we are more that way. So, so how you create a future is very simple. We created a foundation that you use a future constructor. So I'm going to create a future that somebody else can use. So let's call this, call it delay or something. Delay is a good one. Delay future. So we're going to equal that to a new, I wrote all huge now that I've, we'll get smaller. We want a new future. I want you guys to be able to see this signature because it's quite interesting. So when you create a future, what you're trying to tell a future is, I want to get a value at some point in the future. Not now, sometime when somebody's interested, right? You're kind of like packaging it all up. So we're going to say, here's our to-do function. So we create the new future, and I hope that we can set value, set error. Let's come down here a little bit. So now that is the signature. This is how you create a future. And I want to discuss this craziness here. This is where your head gets wrapped into a knot a little bit. So when we want to create a future, we hand the future in the constructor a function to call. It then makes two functions and passes them to me when he wants the value. So set value and set error are functions from the future. That's a little hard to understand, but it makes sense in a minute. So if I want to tell this future that I'm done, or that there was an error, I simply call those methods. So what we're going to do is we're going to say set timeout.
That's right.
And we're going to have a function here. And we're going to say, what we're going to say is when this timeout is done, we're just going to set the value. We're going to set the value to whatever we want. So we could say boo. And that, whoop, forgot one thing. We'll do that in 2 seconds. How's that?
Oh, there you go.
So that is the easiest future you can build. It doesn't even have an error. So this is completely error-free, so I guess this is kind of a bad example.
If something breaks between here and there, you got bigger problems.
So,
in this case.
So what I wanted to do though is I wanted to show you how easy it was to set a value. Let's just play around a little bit. If we wanted to set the error, we could do the same thing and say, versus instead of set value, you could say set error. And what we usually do is create an error object. You say new error, and then you give it some kind of explanation. Now, the cool thing too is about this future, the future knows that it can either only have a set error or set value. If you call set error and set value, it only cared about the first one. If you said error, hey, we're done.
So of all of those callbacks we talked about, the then, the if error, if timed out, only one of those will be ever called. You're guaranteed that two of those isn't ever going to be called, right?
Two of them, let's see.
Let's see, then,
no,
if
okay.
error.
So set timeout and cancel are the same thing basically. So both of those get called.
Okay, because the timeout cancels it, right?
Timeout just cancels it for you. So it's kind of wrapped in some functionality inside the future that I think I should pull out. But
you are guaranteed that your then handler and your if error handler,
yep,
only one of them ever gets called.
And it doesn't even matter what the people that made the future, even that they try to set the value twice or set the error twice, you know, they get crazy like this. It doesn't matter. It just ignores it. So this is how simple it is to create futures.
So let's use it and walk through the process.
Okay.
Of what actually happens. I'm gonna get rid of your error.
Yeah, please. You can have your black marker so you can step on
Okay.
forward. Oh, we haven't even set it off though. What's funny is we created a feature.
Yeah.
We're not even using it yet.
So we talked in one of our other videos about, that's totally backwards.
Yeah.
Okay. I can make computer programs. All right. So even though we've written this, none of this has been executed. And it doesn't get executed until somebody tells the future that it cares about it. The future's really lazy. It's just going to hang around and get away with doing nothing for as long as it can.
This is so cool. I actually was talking to a coworker today, a colleague, and he's like, why do you have to call it in to start that future? And I was like, because we don't know if anybody really cares. So we're going to save those cycles until somebody truly cares.
So I've got my delayed future, now I'm going to say then. And for the sake of it, I'm not even going to hand in a callback here right now.
Okay.
Okay, so the code gets to this point and we call then. The future wakes up. And it's going to run this function
that
we handled it. So now we're going to hit here, we set the timeout, we're going to wait for 2 seconds, and then we'll run this. Boom. So we've called this function that the future supplied us when we supplied it a function. And that tells the future that it's done, and it has a value now. So the future says, I have a value. And then it would call whatever is down in here. In fact, okay, just note that you don't have to give. You can call then without giving a callback, but I will.
Because sometimes there's actually a, you just want to start something off and somebody else wants to respond to it. So you're just like, hey, start it off and I'm going to hand this future to somebody else who cares. That sounds a little weird, but I've done it a lot. This is part of that delegation with futures that you don't get with callbacks. You can say, hey, I want this to start, but someone else is going to handle it and I'll pass it to them. So.
Yeah, and it's really powerful. We use that all the time. So the value gets called, and then
we log
it. Console log value. All of these you can call then as many times as you want, and every time you call then on this future, this function goes into the then bucket. The future's holding a bucket inside with all these thens in it, and when it has a value in this set value function get called, it just goes through the list and says, run this, run this, run this, run this.
So let's talk about it when it's done. This is something that confuses people. Let's say we waited 2 seconds, this one gets called, and then somebody else comes along and has reference to this delay future and then calls then on it. What happens is it gets notified because that 2 seconds has passed and somebody wanted the value.
So if I call then on a future that already has a value, I just get the value.
Right away. It's just like, we've got it. There you go. And if it's an error, the same deal.
So think about how cool this is. I mean, this is really awesome. What if you had a web application that stored user preferences on the server somewhere? And those user preferences are used all over the place in your application. What you could do when the application first loads is you block everything that happens in the application with a loading screen. Says, hang on, we're getting your preferences. Can't do anything until we got all this done.
Because 40 things depend on it.
And we don't know where they are in the program. They're scattered about. We would clean them up if we can, but we lost them. They're somewhere. And then set some globally scoped variable to this preference file so that you can get it.
Right.
Or you can have anywhere you want your preferences.
Yeah, let's erase it. I think they understand that. And I'll get you ready to go with some ammunition.
Okay. So at the very top we could say var prefs, that's a P, equals get prefs, whatever. And this is a future.
Yep. So this goes asynchronously and goes away. But remember, it goes and lets go, and so things continue on, right?
Yeah. So there's no loading screen.
No.
And then somewhere else in the program, in 100 other places in the program, we have
set prefs.
I need to know what your first name is, so we can say prefs dot then. That's a function. Name. Better scope this right. name equals p dot name. If, it doesn't matter where the program gets hit first, if this prefs knows its value, it'll go get it. If not,
Waits until it gets it.
if it knows its value, it'll just run this. If not, it'll go get it, and when it's done, you'll set this.
So usually what happens is when you're doing stuff like this prefs, it's setting up the UI. So what's really cool about using futures is you can set these futures up. Hey, you go get this, you go get that, you go get this. And you hand out these futures to the different functions that are responsible for the UI. Then they know that it's a future, and they just say, hey, then I'm going to fill out, when I get it back, I'm just going to fill out the UI. And you'll see it go, dook, 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 and it's really intriguing.
It's the coolest thing to see for your program to do everything that it can do, and then do everything else as it happens. You draw out this table, and it's got some data in it, but as the data comes down, things just start popping in all over the place. And it's such a powerful tool to manage the complexity of a complicated application that I'd never heard of futures a year and a half ago, and I can't believe I ever lived without them.
And that's what happens with patterns.
Yeah.
You use them, and you go and you're putting this box later on in your profession. Some people are like, you can't use futures, and you're going, what do I do, a callback? And do I do like a callback of callbacks? And how do I handle all these? Should we talk? I'm not sure if we're going way over, but this is a good topic.
Yeah.
So should we talk about tasks?
Let's try and hit tasks really quickly.
So tasks are really important. So we talked a little bit about continuations, and let me draw out real quick what the difference is between continuations and tasks, because it's really critical. We won't go into the continuation. Well, we could, because it would be very simple. Okay, we'll talk about it. So,
you pulled our arm.
Okay, so continuations are like this. This is how simple it is. We're going to draw it out first. A continuation means I need to go get data, and then when it's done, I need to do something else. And when it's done, I need to do something else. So this is how your path of execution looks.
And in each step of this, like say this is 1, the
Yes.
result of this future is
Yes.
1. This 1 gets passed on to the next one, which might have a 2. So we do something with that,
Yeah.
turn it into a 3.
We should say the 1 comes over here and it turns it into a 2. This is responsible for returning a future of some kind of value. So continuations work on the futures.
So the continuation is a lot of futures in a
Yes,
chain,
that's true.
and they're each passing their value 1 to the next, to the
Correct.
next, to the next.
Correct. And that's what's critical. So we can say 3, right? So it's kind of it looks like a stairs, so to speak. And all 3 of these can't go at once. What task does?
Because this depends on that, depends on that.
Yeah. So maybe we're doing calculation in there, right? So
Yeah.
let's say this is started at 0, and now we're just adding those values, and then we finally end up with 3.
Right.
I guess that was kind of bad, but bad math already. Okay, so the difference is now task. We've learned that there's some things that we want to do that stepping, that's continuations, but there's other things that we want to say, hey, we have a bunch of futures, like 20 of them, and we can't do anything until they're all done. So
but we don't really care in what order they get done.
Yeah, exactly.
We just need them all to be done.
We just need them all to be done. So what this does is it creates, this is time, and what it does is it just sends them all out at once, and they could be getting done right here. So this one gets done, right? This one gets done. So down here is the result. So that one gets done there, and that one gets done right here, and this one gets done right here. So then we would be notified, hey, they're all done right there. But they're getting done, they're all going at once. We sent stuff to the server, and they're coming back intermittently, and this is what a task is. Just blast it like a fire hose. This is very, very useful. So we're going to talk about how we can use tasks. We call it a task, and you can put task inside of task. Anyways, it's really kind of cool what you can do. But we'll use a task real quick, and we're going to use fictitious futures that we're not going to write. We'll just call them future 1, future 2. So how you use a task is you simply just create the task, say new task. And at this point, the task has nothing in it, but we need to add a future. So let's add a future. So we'll call this future 1. And let's do another one. Add future. By the way, let's just do it simpler. With add, it can take a variable amount of futures. So we're going to do it the easy way. You could say dot add, dot add, dot add, and so forth, but you can also just do this. It's a lot easier. So now we have 3 futures, right?
We're talking about the implementation of future in the base library
Yes.
that we keep talking about.
So don't think this is the standard, or this is what we use and we've become in love with. So what we've done is we supplied with task 3 futures that have to be done, and they can go simultaneously. They're not dependent on each other. So just go and get it and let me know when you're done. So with task, you have to say task.start. So what start does is it goes and calls then. It says, hey, I'm interested, future, go. Then task says, hey, when any, you can do when any. Let's just do when all first. So when all are done, call this function. Give me the futures back. So this would just be an array of these 3 futures. And futures actually not only have the then on them, but they have the value as well. The value is undefined until it comes back. But now that we know that they're all done, we can check them. So we can actually check to see if some of these had errors. There's other ways to handle errors inside of task as well, but you could say, hey, go get it done, and you could do your, a lot of times you're not even really worried whether or not the data, you're just like, I need this done first and then I'll do something. The beautiful thing is you can also do a when any, so you could like step it incrementally. So this would actually be the single future that it responded to. What else is there? Can't even remember. That's pretty much how I use it.
A cool feature, the way we've set up our futures versus ECMA's promises, is that what I do really quite often is I'll build this future up here and assign a then handler to it.
Oh, that's true.
And then I pass that future into the task. So it's going to do that thing, and it's also going to do whatever we did down here on when all.
Right. And
Which
so
is really cool.
What's really neat about this is you can say there might be 2 or 3 other things that are latched onto this future that care when this future 1 gets done. And then we just add ourselves to, hey, we care when that thing gets done too. So when it comes back, those other things are firing and happening, and it's awesome.
And all the task does is add its own then to each of these futures, and then when it's all done, you get them out the other end.
So we use this constantly with things that we need to blast load. For example, we use task for the way that we use our loader, our base loader that requires files. So there could be 2, there could be 3, there could be 600 files that depend on something. And so it just goes and says, give me all that you can. And it goes and grabs them and says when they're done.
So that's task. That's the one way to collect futures. There's also continuations,
you want to do continuations? I want you to. Or
oh dear.
Okay, I'll do it. Here, because it's kind of a new. We did a reduce function on it. Boy, that would be fun.
We implemented, or I said Jared implemented futures in base last week.
Because we realized that we needed
futures,
them. Continuations. So why I think that futures need to be different than continuations is because remember it's that stepping thing. It's purposefully hand dependent, and I think that's critical to make sure that we understand that. So it's really easy to start a continuation. You can just say new continuation. I guess I should shorten the name, but I'm big on words. And you just pass it the first future. So let's say this is a future 3, like really the value 3. So we know what it is. And then we do a then on it. So that looks really familiar, doesn't it? Here we go, going off the page here. And then we want to get the value. And then down here, what happens is, let's say something else depended on it down here. I'll show you. I just want to write this out first. Value. What continuations expect is a future back. So we have this future. This value from the first future. So what we need to do is we need to return a new future. Remember how we discussed this real quick with the set value. And we're going to say a function set value, and we'll just do that for now. So in here I can say set value is equal to the value up here, and let's just say +1. So then what this does, if future 3 was equal to 3, it come in, this would be a 3, we have reference to that, then when this future gets called by this guy, this changes that to 3, it pluses by 1, now we've got 4. So now, instead of going like, how do I draw this, like this huge, you'll notice JavaScript does this.
This is especially a problem in
Node.
Node. Call it the Pyramid of Doom. It has more colorful names. It has much more colorful names.
Yeah. A lot more colorful, but you notice that your code gets deeper and deeper and deeper.
And you've got so many curly braces.
Oh no, it's on the bottom.
Here.
Remember, you don't even know what they mean. You're just like, oh, those are a bunch of 3s.
You know how when you put your cursor on here, your text editor will somehow highlight the matching curly brace?
You can't even see it, it's so far
It's
up.
like way up there. And don't you dare delete one of these, because you'll never be able to rebalance this, ever. You might as well start over.
So this is the continuation, so you can look at this as, hey, this is step 1, this is step 2. We can take that value and console log it now that we're done. And that is gorgeous.
It's a program that reads down like programs were meant to be read, instead of sideways.
Yeah. Yep. And we really pushed continuation. We were walking to a meeting, and we got thinking of how to use a continuation. We're not going to discuss the implementation. Maybe if we get some comments, we'll discuss it next time. But we actually use continuation with a reduce on an array of things. So what happened, we had something come from the database, if I understand correctly, a list of names. And they were given to us in order.
Yeah, in alphabetical order.
Alphabetical order. So we needed to maintain that order when we appended them to the DOM.
Yeah, it wasn't a list of, what was it? So there's 2 related objects here. The server gave me these objects in order, and I needed to display their related counterparts in that order on a table. And I couldn't use a task, because if I use a task to load these related objects, I'll get them back in who knows what.
Different every time. Yep.
Yeah, and it won't be consistent. But so I needed to load these things in the order that they were given me. And they were in an array. So we used
the reduce.
We used JavaScript's array reduce to put together a continuation, like 3 lines.
Oh, it's gorgeous.
It was pretty beautiful.
Because we're iterating through the data, and we're like, hey, we need this data to be the same, so we're iterating through it, and we're adding a then to the continuation. And we pass the continuation as the result of that combination. And we handed a continuation, and then at the very end we get the last continuation, and we're done.
Say that, and that's it.
And
It was cool.
It was beautiful.
Take that, ECMA.
Yeah, that's right.
Just kidding. We love you.
We do love them. But this is the why we believe it doesn't take much work to make a future into a continuation. I wouldn't even mind if the future had something to like 2 continuation, and that's where you'd start, and then you could say then on it and know that it's going to be continuous. I just feel like we were shoving too much into the future.
Yeah, we really decided that the future, to put the continuation on the future confuses the future, gives it too many jobs. It really has one job, and that's to promise a value at some time in the future.
That's the power strip that we're talking about. That's its job.
It doesn't do anything else. And then we add the continuation on later.
Yep.
Extend the prototype. This is JavaScript for crying out loud.
So now that we got the continuation, we could say future.prototype.toContinuation and do this first little thing for them, and then bam, they're off to the running.
Yeah. So that's our opinion for the standards bodies.
And that's it, I'm thinking. You have anything else to say?
Thanks for sticking through the video. That was a marathon, but this is really good stuff. And all of these things are we keep mentioning this base library. It's open source, it's on GitHub. We'll put a link in the description to the video, and very soon we're going to have some good documentation on this library.
We're working on it.
At our website. I've just about got it to where I want to publish it.
But one more thing that I wanted to say is, remember how we talked about futures today? Because the way that I thought, this stimulated a thought that we're going to talk about. I had an epiphany a few months ago. something that kind of started us making these videos. And this is crucial. This principle is crucial to understand that, and stay tuned because it has to do with expression trees and futures. And but you need to understand this stuff in order that we can talk about it. Anyways, thank you.
That's it. Thanks.